Sherbrooke OEM never ceases to innovate in its approach to designing equipment and factories. Early on, OEM focused on manufacturing customized equipment for a variety of industries. Its experience and analytical expertise in design have led OEM to undertake larger and larger projects, integrating several pieces of equipment and participating in the design aspect. Constantly driven to provide valuable solutions in terms of operational innovation, OEM began expanding its work in the field of recycling, offering fully equipped solid waste material treatment plants. The first generations of highly durable, large-capacity construction and demolition debris (C&D) treatment plants were then developed. For several years, OEM set the design standards for the industry. Designs that involve separating C&D materials into two lines, lines A and B, followed by the optimization of line B to automate and mechanize the sorting of material, a task impossible to perform manually with any efficiency. The inclusion of Eagle Vision optical sorting units enabled OEM to provide its clients with a new generation of highly automated sorting centers. The design concepts for handling materials were then completely revised. More sophisticated plants were made available to different markets, such as C&D, commingled containers, single stream, and household waste. Several specialized plants were subsequently designed and constructed. Their common goal, to increase the recycling rate of recyclable materials while reducing the manual labor required. To continue setting the industry standard, OEM came up with the idea to consolidate various plant designs into a single design, one that would make it possible to handle different types of waste, while at the same time ensure ease of operation with flexible equipment that can adapt to different types of waste. Thus, the Boomerang system, a multi-material center, was born. Several designs were studied and evaluated by the engineering department, with each member contributing knowledge and experience towards developing a flexible operational process. Patent requests were submitted, and in July 2010, the first Boomerang system in the world was launched. The main processing steps in this unique plant are 3 receiving areas to feed the system, 1 feed of C&D, commercial and other dry materials, 2 feed of household waste, 3 feed of large items and wood to be ground or reduced in size. C&D and commercial materials go through a vibrating screen that separates large pieces from small. Large items are sorted manually, and small ones go through the automated line. Household waste goes through a trommel where most of the organic matter is removed. Then large items are sent for manual sorting, while smaller ones go through the automated line. Materials headed for the grinder first pass through a quality control process to remove any undesirable material. They then go into the trommel and follow the same path as the 2 other feeds. Manual sorting of large items may or may not be conducted depending on the type of waste being treated. Workers are allocated to parts of the plant based on the percentage of salvageable materials. With the exception of wood sent to the grinder, directly unloaded into an accumulation bin once an electromagnet has removed nails and other pieces of crushed iron, all other small items not manually sorted pass through a series of equipment. 1. An electromagnet that removes ferrous components. 2. Star gear screens that remove fine and ultrafine materials. 3. Air classifiers that sort light materials, such as paper and plastics, from heavy materials, mainly aggregates and glass, and the rest of the material. Light materials are sent to a fiber screen that separates 2D fiber from 3D materials. The fiber can then be inspected using a quality control conveyor. Heavy materials are put into an accumulation bin. The rest of the material is sent through a series of optical sorters. 4. A total of 3 optical sorting units automatically sort wood and/or fiber, as well as different types of plastic. Only 1 quality control process is required for each optically sorted material. 5. At the end of the line, an eddy current separator removes all non-ferrous components from the material. All large materials that are sorted manually are put in bins that are emptied by a wheel loader. All optically sorted materials are put in bins that empty automatically. These bins feed a press where the materials are baled. A quality control process is carried out on all material. The finished products are then baled. The plant has been designed providing access to a container loading pit for all sorted materials inside the building. The equipment sequence is programmed so that when the type of waste to be handled changes, some of the conveyors are reversible while the optical sorting units automatically change the type of material to be sorted. When processing household waste, the trommel separates large items from small ones. A quality control process is carried out to remove the desired materials, cardboard, plastics, and so on. Once the ferrous components have been extracted by the electromagnet, the organic part is removed by sifting. All light 2D materials, mainly plastic bags, are also removed. Heavier items and 3D materials go through a first optical sorting that removes unopened bags and diapers, then a second and third sorting where PET and HDPE are removed. Finally, non-ferrous elements are removed using an eddy current separator. When C&D is processed, an initial vibrating screen separates large items from small ones. Large items are sorted manually by type, wood, cardboard, iron, plastics, and so on, while small items are sent to the automated line. Ferrous components and fine material are removed first, followed by aggregates using an air classifier. Fiber and plastic film are then removed. The rest of the material goes through optical sorting where the desired wood and plastics are sorted by NIR. Finally, an eddy current separator removes non-ferrous components. For the commercial waste, cardboard is put on the manual sorting line where a quality control process is conducted. The remainder of the material goes through a secondary screening where the organic part is removed. The rest of the reclaimed material is composed of fibers sorted using a 2D separator, wood and plastics sorted using optical sorting, and metals sorted using an electromagnet and eddy current sorting process. When processing plastics, the bales of plastic are first sent to the grinder. Once in pieces, the plastic is cleaned to remove impurities such as metal using an electromagnet and the eddy current sorting process, and fine materials and sand are removed using star gear. Finally, the plastic is sorted by type, plastics 1 to 7 using NIR. The finished products are then baled. When processing compost or organics, it is first fed into the trommel where clumps are broken apart. Next, the compost goes through an electromagnet and then 2 star gear screens. Fine materials, which are 99% organic, and small items, 90% organic, are removed. Heavy items, which are wood 90% of the time, are also separated using an air separator, and plastic remnants are then removed using NIR. Any 2D material such as paper and plastic film is also removed. The boomerang system designed by Sherbrooke O.E.M. offers incomparable operational flexibility. By handling several types of waste materials under one roof, the Multi-Material Center provides numerous benefits. Integration of advanced equipment that offers superior recycling rates and capacity. Minimal labor is required to operate the Multi-Material Center. And advantageous economic value compared to having several sorting centers based on type of waste.